Hello students, in this video we are going to learn homogeneous linear differential equation of nth order. So a0 d to the power of n y by dx to the power of n plus a1 d to the power of n minus 1 y divided by dx to the power of n minus 1 plus a2 d to the power of n minus 2 y divided by dx to the power of n minus 2 plus dash an into y equals to 0 is called a homogeneous linear differential equation of nth order. Okay, and here a0 comma a1 comma a2 comma dash an are constants. So how to solve this homogeneous linear differential equation of nth order? So we have some few steps to solve it. Let's see what are the steps. So here are the steps. First step 1 is write the equation in symbolic form. So that is a0 d to the power of n plus a1 d to the power of n minus 1 plus a2 d to the power of n minus 2 plus dash an into y equals to 0, and it is denoting with f of d into y equals to 0. Next, second step is write down the auxiliary equation. You know very well what is auxiliary equation because in the previous exercise we learned about the auxiliary equation. So just you substitute d equals to m, that is the auxiliary equation. So a0 m to the power of n, a1 m to the power of n minus 1 plus a2 m to the power of n minus 2 plus dash an equals to 0. This auxiliary equation is denoting with f of m equals to 0. So next step 3 is solve the equation 3. Equation 3 means this auxiliary equation you have to solve by using factorization or any other methods. So then you will get the roots which are m1 m2 dash mn. So okay, next step 4 is after finding the roots for the given equation according to the nature of the roots that of auxiliary equation. Here roots of the auxiliary equation means m1 m2 dash mn. So write down the general solution of the one as given in the following table. So what is the table once you observe it? So here is a table, n real and distinct roots. See, the roots of the auxiliary equations are denoting with m1 m2 dash mn. If these roots are real and distinct means different, then the solution for the given homogeneous linear differential equation is c1 into e to the power of m1x plus c2 into e to the power of m2x plus dash plus cn into e to the power of mnx. Next to m1 m1 m3 m4 dash mn. That means in these roots the first two roots are same, remaining are different, and that too they are real and equal, and remaining roots are real and different. So then when the two roots are equal, then here c1 plus c2 into x e to the power of m1x will come. For remaining roots the solution is c3 e to the power of m3x plus dash cn e to the power of mnx. So this is a solution for given homogeneous linear differential equation in the second case. Next, in the third case, if the three roots are equal, remaining are different and real numbers, these all. So then c1 plus c2x plus c3x square into e to the power of m1x, and for remaining roots c4 e to the power of m4x plus dash cn e to the power of mnx. Next to fourth one, two roots of auxiliary equation are conjugate complex. Complex numbers means you know very well alpha plus I beta, alpha minus I beta. Okay, and the remaining roots are real and distinct. So then when the two roots are complex numbers, then e to the power of alpha x into c1 into cos beta x plus c2 into sin beta x. You know very well this type of questions you did in the previous exercise. Next, for remaining roots, c3 into e to the power of m3x plus dada cn into e to the power of mnx. Okay. Next, to fifth point, two equal complex conjugate roots. Okay, and the remaining roots are real and distinct. So then e to the power of alpha x, see the two roots conjugate at the same time equal. So then e to the power of alpha x into c1 plus c2x into cos beta x plus c3 plus c4 into x sin beta x. And for remaining roots, c5 into e to the power of m5 x plus dash plus cn into e to the power of mn x. So these are the 5 important points to solve the homogeneous linear differential equation of the nth order. So let's start the exercise problems. That is second exercise. Exercise 1.2. Solve. First question, y triple dash minus 9y double dash plus 23y dash minus 15y equals to 0. So here y triple dash means d cube y by dx cube. Y double dash means d square y by dx square. Y dash means dy by dx. Okay, so then write symbolical representation. So it's symbolic representation is y triple dash means that is d cube minus 9 d square plus 23 d minus 15 into y equals to 0. Here d cube means d cube by dx cube, d square means d square by dx square, d means d by dx. Okay, so you know very well about these all in the previous exercise. Now it's auxiliary equation. So it's auxiliary equation is, what is auxiliary equation? Replace the d with m. So m cube minus 9m square plus 23 m minus 15 equals to 0. So now we have to find out the roots. But it is not a quadratic equation, it is a cubic equation. So cubic polynomial equation, so factorization is not possible right now. So that is why use a synthetic division method. Synthetic division method. But to use this synthetic division method, first we have to find out one root by substituting the different m values. So first I am going to substitute m equals to 1. So 1 cube minus 9 into 1 square plus 23 into 1 minus 15. 1 minus 9 plus 23 minus 15. So 1 plus 23, 24, 9 minus 15, it is also 24. So 24 minus 24 is 0. So when m equals to 1, we got the answer 0. Then definitely m minus 1 will be a 1 root. Okay. So then m minus 1 is a root for auxiliary equation. Next we have to find out two more roots. So to find out the two roots, use a synthetic division method. So in the synthetic division method, here first you write the all coefficients in the auxiliary equation. Here m cube coefficient is 1, m square coefficient is minus 9, m coefficient is 23, and constant is minus 15. And we already found one root, that is m equals to 1. So 1 right here. Okay, so this first number will come as it is. Next 1 multiply with this. 1 ones are 1. Next add these two numbers. Minus 9 plus 1 is minus 8. Next this minus 8 multiply with this 1, so it is minus 8. 23 minus 8 is 15. Okay, next to 15 multiply with this 1, so then here 15 will come. Now add these two. Minus 15 plus 15 is 0. Okay, so finally we got the 0 now. Now m cube minus 9m square plus 23m minus 15 is equals to, already one factor completed now. What is that? M minus 1 into, here start with m square, because the original auxiliary equation is m cube na? So then start with m square minus here 8m, next 15. Okay, it is equals to 0. Now we got the quadratic equation. Then you can do factorization here. M minus 1 into m square, minus 8m can write as a minus 5m minus 3m plus 15 equals to 0. So m minus 1 into m minus 1 into, here take the m common from the first two terms, m minus 5, next to minus 3 common, m minus 5 equals to 0. So m minus 1 into m minus 5 common into m minus 3 equals to 0. So finally we got the product of three different polynomials. So m minus 1 equals to 0, m minus 5, first I am writing m minus 3 ascending order, next m minus 5 equals 0. Here m equals to 1, here m equals to 3, here m equals to 5. So therefore here roots are which type of numbers? Real numbers and distinct. Distinct means different. So when the roots are real and distinct, as per the table given in the textbook, just now I was explained, the general solution of the given homogeneous differential equation is y equals to c1 into e to the power of m1x plus c2 into e to the power of m2x plus c3 into e to the power of m3x. Then y equals to c1 into e to the power of m1 means the first root, what is that? 1, plus c2 into e to the power of m2 means second root, 3x, c3 into e to the power of third root, 5. So this is our required answer. Second question, d cube y by dx cube minus 4 d square y by dx square plus dy by dx plus 6y equals to 0. Let's write its symbolical representation, that is d cube minus 4 d square plus d plus 6 into y equals to 0. Next its auxiliary equation is m cube minus 4m square plus m plus 6 equals to 0. So now let's find out the m value, but it is a cubic equation, so that is why first I am going to find out the one root. Let m equals to 1, so 1 cube minus 4 into 1 square plus 1 plus 6, it is equals to 1 minus 4 plus 1 plus 6. So 1 plus 6 7, 7 plus 1 8, 8 minus 4 is 4, but actually we need to get the 0 answer. So now let's substitute the m equals to minus 1. So minus 1 whole cube minus 4 into minus 1 whole square plus minus 1 plus 6. Minus 1 whole cube minus 1 minus 1 whole square plus 1, so minus 4 minus 1 plus 6. Minus 1 minus 4 minus 1 is minus 6, next to plus 6, so it is equals to 0. So when m equals to minus 1, we got the 0 answer. Therefore m plus 1 is a one factor of auxiliary equation. Now use a synthetic division method. So synthetic division method. So first write the all coefficients of auxiliary equation. So here 1 minus 4 1 6. Next to the first factor is what? The m plus 1 is a factor, na? So then m value is minus 1 here, and the first number write as it is. 1 into minus 1 is minus 1. Next do addition. Minus 4 minus 1 minus 5. Next multiply with minus 1, so it is plus 5. 1 plus 5 is 6, and multiply with minus 1. 6 into minus 1 minus 6. Now do addition, it is a 0. So finally m cube minus 4m square plus m plus 6 can write as a one factor is m plus 1, and another factor is here m square. These are the coefficients of the resulting polynomial m square minus 5m plus 6. So it is equals to what? 0. Now do factorization of this quadratic polynomial. So m plus 1 into m square minus 2m minus 3m plus 6 equals to 0. So m plus 1 into, here take the m common, m minus 2 minus 3 common, m minus 2 equals to 0. So here m equals to minus 1, here m equals to 2, here m equals to 3. So the three roots are minus 1, 2 and 3. And the three roots are real number and different numbers. Am I right? So the roots are, so then the general solution is y equals to c1 into e to the power of m1x plus c2 into e to the power of m2x plus c3 into e to the power of m3x. So then it is equals to c1 into e to the power of m1, that is minus 1 into x plus c2 into e to the power of 2x plus c3 into e to the power of 3x. So it is equals to c1 into e to the power of minus x plus c2 into e to the power of 2x plus c3 into e to the power of 3x is our required answer. Third bit, first problem, d cube minus 5d square plus 8d minus 4 into y equals to 0. It is already in the symbolic form. Let's write its auxiliary equation. The auxiliary equation is substitute d equals to m. So m cube minus m square minus 5m square plus 8m minus 4 equals to 0. Now let's find out one root by substituting different m values. So first I am going to substitute m equals to 1. So 1 cube minus 5 into 1 square plus 8 into 1 minus 4. 1 cube is 1 minus 5 plus 8 minus 4. Here 1 plus 8 is 9. 5 minus 5 minus 4 is minus 9 equals to 0. So therefore m minus 1 is a factor or one root factor of auxiliary equation. So by using the synthetic division method, let's find out the remaining two factors. Yeah, first of all I am going to write the all coefficients of the auxiliary equation. 1 minus 5, 8 minus 4. Next here m value, what is that m value? 1 is a m value. Next write the first number as it is. 1 into 1 is 1, and do addition. Minus 5 plus 1 is minus 4. Minus 4 into 1 is minus 4, and 8 plus minus 4 is plus 4. 4 into 1 is 4, and minus 4 plus 4 is 0. So therefore m minus 1 into here it is coefficients of the resulting polynomial. So m square minus 4m plus 4. Now do factorization of this quadratic polynomial. M square minus 4m I am writing as a minus 2m plus 4 equals to 0. Then m minus 1 into, so here I am taking the m common, m minus 2. So the roots are m equals to 1, m equals to 2, m equals to 2. So the all roots are, the three roots are real and distinct. So roots are real and distinct. And observe carefully, here two roots are same. Okay. So then the solution is y equals to c1 plus c2x into e power m1x plus c3 into e to the power of m2x. So c1 plus c2 into x e to the power of m1 means this same root is there, that is a m1, 2x plus c3 into m2 means this different one, e to the power of 1 into x. So the answer is c1 plus c2 into x e to the power of 2x plus c3 into e to the power of x. Second question, d cube minus d square minus 8d plus 12 into y equals to 0. Its auxiliary equation is m cube minus m square minus 8m plus 12 equals to 0. Next, find out the one root for this. So first I am going to substitute m equals to 1. So 1 cube minus 1 square minus 8 into 1 plus 12 equals to 0. 1 minus 1 minus 8 plus 12 equals to 0. So here 1 plus 12 is 13 and minus 1 minus 8 is minus 9, but it is not equals to 0. So then substitute another m value, minus 1. So minus 1 whole cube minus of minus 1 whole square minus 8 into minus 1 plus 12. So it is equals to minus 1 whole cube minus 1 whole square is plus 1 and minus 8 into minus 1 is plus 8 plus 12. So minus 1 is minus 2 plus 20. It is also not equals to 0. Then go for another number 2. So 2 cube minus 2 square minus 8 into 2 plus 12. So 2 cube 8, 2 square 4, 8 to the 16 plus 12. So 8 plus 12 is 20, minus 4 minus 16 is minus 20, it is equals to 0. So therefore m minus 2 is a factor of auxiliary equation. Now using the synthetic division method, so first of all the factors of auxiliary coefficients of auxiliary equation are 1, minus 8 plus 12, and the m value is 2 is the m value. So here write the first number as it is, 1 into 2 is 2 and minus 1 plus 2 is plus 1 into 2 is 2, minus 8 plus 2 is minus 6 into 2 is minus 12. So here is a 0. So therefore the first factor is m minus 2. Next factor is, here use these coefficients, m square plus m minus 6 equals to 0. Now m minus 2 into m square plus m can write as a 3m minus 2m minus 6 equals 0. Then m minus 2 into, here take the m common, m plus 3. Next minus 2 common, m plus 3 equals to 0. So the roots are 2, minus 3 and 2, and here two roots are same, okay, and one is different. So then in this case the roots are real and distinct. So then the solution is y equals to c1 plus c2 into x e to the power of m1x plus c3 into e to the power of m2x. So then y equals to c1 plus c2 into x. Here take the m1 as a equal roots as a m1. So e to the power of 2x plus c3 into e to the power of minus 3x is our required answer. Fourth bit, first problem, d cube y by dx cube minus 5d square y by dx square plus 7 dy by dx minus 3y equals to 0. Let's write in the symbolical representation, that is d cube minus 5d square plus 7d minus 3 into y equals to 0. Next, its auxiliary equation is m cube minus 5m square plus 7m minus 3 equals to 0. Now let's find out one factor. To find the factor, substitute different m values. First I am substituting m equals to 1. 1 cube minus 5 into 1 square plus 7 into 1 minus 3 equals to 0. So 1 minus 5 plus 7 minus 3 equals to 7 minus 3. So here 1 plus 7 is 8, minus 5 minus 3 is minus 8, it is equals to 0. So therefore m minus 1 is a factor of auxiliary equation. Now using the synthetic division method, let's find out the remaining factors. So the coefficients of the auxiliary equations are 1, minus 5, 7, minus 3, and the m value, that is 1, m equals to 1. So write the first number as it is 1. 1 into 1 is 1, and the addition of minus 5 and 1 is minus 4. Minus 4 into 1 is minus 4. Addition of these two is 3. 3 into 1 is 3, and here is a 0. So therefore the auxiliary equation is what? m cube minus 5m square plus 7m minus 3 equals to 0. At this place we can write first factor m minus 1 into, here this is the second factor coefficients, so m square minus 4m plus 3 equals to 0. Now do factorization. M minus 1 into m square minus 4m I am writing as a minus 3m minus m plus 3 equals to 0. Now m minus 1 into, here m is a common, m minus 3, here minus 1 common, m minus 3, it is equals to 0. Then m minus 1 into m minus 3 into m minus 1 equals to 0. So therefore roots are 1, 3 and 1, and these are the real numbers and different, and two roots are equal. So then the general solution is c1 plus c2 into x e to the power of m1x plus c3 into e to the power of m2x. So c1 plus c2x into, here m1 is, the equal roots are m1, so 1 into x, c3 equals to e to the power of 3x. So c1 plus c2 into x e to the power of x, c3 into e to the power of 3x is our required answer. Second question, d cube y by dx cube minus 7d square y by dx square plus 16 dy by dx minus 12y equals to 0. So its a symbolical representation is d cube minus 7d square plus 16d minus 12 into y equals to 0. Next, its auxiliary equation is m cube minus 7m square plus 16m minus 12 equals to 0. Now let's find out the factor for this. So that is why substitute m equals to 1. So 1 cube minus 7 into 1 square plus 16 into 1 minus 12 equals to 1 minus 7 plus 16. minus 12. So 1 plus 16 is 17, and 7 minus 2 minus 7 minus 12 is 19, but it is not equals to 0. Then go for next m value, that is minus 1. So minus 1 whole cube minus 7 into minus 1 whole square plus 16 into minus 1 minus 12. Minus 1 whole cube minus 1 minus 7 minus 16 minus 12. So here all are negative numbers, so we will not get the 0. Then go for next m value, that is 2. So 2 cube minus 7 into 2 square plus 16 into 2 minus 12. 2 cube 8 minus 7 into 2 square. 2 square 4. 4 sevens are 28. 16 twos are 32 minus 12. So here 8 plus 32 is 40, and minus 28 minus 12 is minus 40. It is equals to 0. Therefore m minus 2 is a factor of auxiliary equation. Next, to use synthetic division method. Write all coefficients of the auxiliary equation. So here 1 minus 7, 16 minus 12, and the m value is 2 is a m value. So write the first number as it is, and 1 into 2 is 2, and addition minus 7 plus 2 minus 5. Minus 5 into 2 is minus 10, and its addition is plus 6. 6 into 2 is 12, its addition is 0. So therefore first I am writing the auxiliary equation, 7m square plus 16m minus 12 equals to 0, and one factor is m minus 2. The second factor is, these are the coefficients of the second factor, m square minus 5m plus 6 equals to 0. So m minus 2 into m square minus 3m minus 2m plus 6 equals to 0. Then m minus 2 into, here take the m common from the first two terms, minus 2 common from the next two terms. It is equals to 0. So the roots are 2, 3 and 2, and these are the real and different, and two roots are equal. So the general solution of the given homogeneous linear differential equation is c1 plus c2 into x into e to the power of m1x plus c3 into e to the power of m2x. So c1 plus c2 into x, here m1 means the equal roots are m1, so that is 2. E to the power of 2x plus c3 into e to the power of 3x is our required answer. Fifth question, y triple dash minus 2 y double dash minus 3 y dash equals to 0. So its a symbolical representation is y triple dash means dq minus 2d square minus 3d into y equals to 0. In this question constant number missed, so anyhow let's find out the roots for the auxiliary equation. So here auxiliary equation is m cube minus 2m square minus 3m equals to 0. So first of all we can take the m common from the three terms. So m square minus 2m minus 3 equals to 0. So then m bracket of, here m square minus 2m can write as a minus 3m plus m minus 3 equals to 0. So m bracket of, take the m common, m minus 3 plus 1 common, m minus 3 equals to 0. Then m into m minus 3 is common, m plus 1 equals to 0. Then m equals to 0, m minus 3 equals 0, m plus 1 equals to 0. So here m equals to 3, here m equals to minus 1. So here the roots are real and different. So then the solution is C1 into e to the power of m1x plus C2 into e to the power of m2x plus C3 into e to the power of m3x. So then y equals to C1 into e to the power of m1. m1 means 0 into x plus C2 into e to the power of m2 means take the negative number minus 1 into x plus C3 into e to the power of 3 into x. So y equals to C1 into e to the power of 0 into x is 0. E to the power of 0 is how much? Is a 1 plus C2 into e to the power of minus x plus C3 into e to the power of 3x. So y equals to C1 plus C2 into e to the power of minus x plus C3 into e to the power of 3x is our required answer. Sixth question, d cube x by dt cube plus 2 d square x by dt square minus 8 dx by dt equals to 0. So here it's a symbolical representation is d cube plus 2d square minus 8d equals to 8d into x equals to 0. Now its auxiliary equation is m cube plus 2m square minus 8m equals to 0. Take the m common, so m plus 2m minus 8, m square will come, m into m square, here 2m can write as a 4m minus 2m minus 8 equals to 0. Here m into, take the m common from the first two terms, next minus 2 common from the next two terms equals to 0. So m into m plus 4 into m minus 2 equals to 0. Then m equals to 0, m plus 4 equals to 0, m minus 2 equals to 0. Here m equals to minus 4, here m equals to 2. So here the roots are real and distinct. So then the solution is, a solution is in the variable x. Okay, C1 into e to the power of m1t plus C2 into e to the power of m2t plus C3 into e to the power of m3t. So then x equals to, so C1 into e to the power of m1 0 into t plus C2 into e to the power of m2, that is minus 4 into t. Next take the cm2 as a 2. So to get the textbook answer I am taking the m2 as a 2 plus c3 into e to the power of minus 4 into t. So x equals to c1 into e to the power of 0 plus c2 into e to the power of 2t, c3 into e to the power of minus 4t. So x equals to c1 into 1, because e to the power of 0 answer is 1, e to the power of 2t plus c3 into e to the power of minus 4t. So c1 plus c2 into e to the power of 2t, c3 into e to the power of minus 4t is our required answer. Seventh question, d cube minus 2d square minus d plus 2 into y equals to 0. So its auxiliary equation is m cube minus 2m square minus m plus 2 equals to 0. Let's find out the one factor for this. So that is why I am going to substitute m equals to 1. So 1 cube minus 2 into 1 square minus 1 plus 2. 1 cube 1 minus 2 minus 1 plus 2. Here 1 plus 2 is 3, minus 2 minus 1 is minus 3. So it is equals to 0. So therefore m minus 1 is a factor of auxiliary equation. Now by the synthetic division method, let's find out the remaining factors. So the coefficients of auxiliary equations are 1 minus 2 minus 1 2, and the m value is 1 is a m value. Okay, so m equals to 1. Write first number as it is, 1 into 1 1, and the addition is minus 1. Minus 1 into 1 is minus 1. The addition is minus 2. Minus 2 into 1 is minus 2. The addition is 0. So therefore m cube minus 2m square minus m plus 2 equals to 0. Here let's take the first factor m minus 1, and the next factor coefficients are 1 minus 1 minus 2. So then m square minus m minus 2 equals to 0. Now do factorization of m square minus m minus 2. Here minus m I am writing as a minus 2m plus m minus 2 equals 0. Then here m minus 1 into, here take the m common from the first two terms and 1 common from the next two terms. So then it is equals to, so here m equals to 1, here m equals to 2, here m equals to minus 1. So the roots are real and different. So then the general solution of the given question is y equals to c1 into e to the power of m1x plus c2 into e to the power of m2x plus c3 into e to the power of m3x. So here m1 y equals to c1 into e to the power of, take the negative answer m1, next positive answer smaller one is 1, so 1 into x plus c3 into e to the power of 2 into x. Then y equals to c1 into e to the power of minus x plus c2 into e to the power of x plus c3 into e to the power of 2x is our required answer. Eighth question, dq minus 2d square minus 4d plus 8 into y equals to 0. Its auxiliary equation is m cube minus 2m square minus 4m plus 8 equals to 0. So let's take the one m value 1. So 1 cube minus 2 into 1 square minus 4 into 1 plus 8. So 1 cube 1 minus 2 minus 4 plus 8. So 1 plus 8 is 9, minus 2 minus 4 minus 6, but it is not equals to 0. So then take the another m value. So minus 1. So minus 1 whole cube minus 2 into minus 1 whole square minus 4 into minus 1 plus 8. Minus 1 whole cube minus 1, here minus 2 plus 4 plus 8. Minus 1 minus 2 minus 3. 4 plus 8 is 12. It is also not equals to 0. Okay. So then let's take another m value. 2 is a m value. So 2 cube minus 2 into 2 square minus 4 into 2 plus 8. 2 cube 8. 2 square 4. 4 2 is 8. 4 2 is 8 plus 8. 8 plus 8 is 16. Minus 8 minus 8 minus 16 equals to 0. So therefore m minus 2 is a factor of auxiliary equation. Now use the synthetic division method to find out the remaining factors. So first write the coefficients of the auxiliary equation. 1 minus 2 minus 4 8. Next the m value is what? 2 is the m value. So first number write as it is. 1 into 2 2, and their addition is 0. 0 into 2 is 0, and their addition is minus 4. Minus 4 into 2 minus 8, their addition is 0. So m cube minus 2m square minus 4m plus 8 equals 0. Then its factorization is first factor m minus 2, second factor coefficients are here. So then m square plus 0 into m minus 4 equals to 0. So then m minus 2 into m square minus 4 equals to 0. So m minus 2 into m square, 4 can write as a 2 square equals 0. M minus 2 into, here a square minus b square formula, that is a minus b into a plus b. So then m minus 2 equals 0. Again m minus 2 equals 0. M plus 2 equals 0. Then here m equals to 2, here m equals to 2, here m equals to m equals to minus 2. So here the roots are real and different. So and the two roots are equal. So then the solution is y equals to c1 plus c2 into x e to the power of m1x plus c3 into e to the power of m2x. So y equals to, so here m1, equal roots are m1 and this is a m2. So then c1 plus c2 into x e to the power of 2x plus c3 into e to the power of minus 2x is our required answer. Ninth question, d cube minus 3d square plus 3d minus 1 into y equals to 0. So its auxiliary equation is m cube minus 3m square plus 3m minus 1 equals to 0. So let's check the m equals to 1. So 1 cube minus 3 into 1 square plus 3 into 1 minus 1. 1 cube 1 minus 3 plus 3 minus 1. So here 1 plus 3 is 4, minus 3 minus 1 minus 4, it is equals to 0. Therefore m minus 1 is a first factor of the auxiliary equation. Now using the synthetic division method, let's find out the remaining factors. So here the coefficients of auxiliary equations are 1, minus 3, 3, minus 1, and the first m value is 1. So here write the first number as it is, 1 into 1 1, and their addition is minus 2, minus 2 into 1 minus 2, their addition is 1, 1 into 1 is 1, and their addition is 0. So therefore m cube minus 3m square, so m minus 1 into, these are the coefficients of the second factor, m square minus 2m plus 1 equals to 0. So m minus 1 into m square minus m plus 1 equals to 0. Now m minus 1 into, here take the m common from the first two terms, and here minus 1 common from the next two terms, it is equals to 0. So the roots are 1 1 1, all are real number and equal. Okay, so then the solution is y equals to c1 plus c2x plus c3x square into e to the power of m1x e to the power of mx. So y equals to c1 plus c2x plus c3x square into e to the power of, here m value 1 1 into x, then y equals to c1 plus c2x plus c3x square into e to the power of 1 into x is our required answer. 10th question, d cube x by dt cube plus d square x by dt square plus 4 dx by dt plus 4x equals to 0. So its a symbolical representation is d cube plus d square plus 4d plus 4 into x equals to 0. Then its auxiliary equation is m cube plus m square plus 4m plus 4 equals to 0. Let's take the m equals to 1. So if you substituting m equals to 1, we will not get the 0 answer because all are positive values. That is why substitute m equals to minus 1. So minus 1 whole cube plus minus 1 whole square plus 4 into minus 1 plus 4. Minus 1 whole cube minus 1, here plus 1 minus 4 plus 4, minus 1 minus 4 is minus 5, 1 plus 4 is plus 5, it is equals to 0. So therefore the first factor is m plus 1 is factor of auxiliary equation. Now using the synthetic division method. So use the synthetic division method. First write the all coefficients of the auxiliary equation. So here 1, 1, 4, 4, and the first m value is -1, and write the first number as it is. 1 into -1 -1, and their addition is 0. 0 into -1 is 0, and their addition is +4. 4 into -1 -4, 0. So therefore m cube plus m square plus 4m plus 4 equals 0. Here m plus 1 is the first factor, and these are the coefficients of the next factor. So that is m square plus 0 into m plus 4 equals to 0. So m plus 1 into m square plus 4 equals to 0. M plus 1 into m square. So here 4 can write as a minus of, so m plus 1 equals 0, one answer. M square plus 4 is 0 is another answer. Here m equals to -1. Here m square equals to -4. M equals to root -4, and m equals to plus or minus 2i, because root -4 can write as a root -1 into root 4. Root -1 value is I, root 4 answer 2, so 2i, and put the plus or minus. Okay, so here one root is real number, but second root is complex numbers. Remaining two roots are complex numbers. So in this case the solution is, so y equals to, sorry not y, x equals to for real roots c1 into e to the power of m1x, and for the complex roots c2 into cos, e to the power of alpha x into, here not x, c1 into e to the power of m1t plus c2 into e to the power of alpha t bracket of c2 into cos beta t plus c3 into sin beta t. Then x equals to c1 into e to the power of -1 into t plus e to the power of alpha t. Here actually 2i compare with plus or minus 2i compare with alpha plus or minus beta I. Then alpha value 0, beta value 2. So then 0 into t plus c2 into cos 2t plus c3 into sin 2t. So then x equals to c1 into e to the power of minus t, e to the power of 0 into t, e to the power of 0, c2 into e to the power of 0 answer how much? It is 1. So c2 into cos 2t plus c3 into sin 2t. So the final answer is c1 into e to the power of minus t plus c2 into cos 2t plus c3 into sin 2t is our required answer. 11th bit first problem, d cube y by dx cube plus y equals to 0. Its a symbolical representation is d cube plus 1 into y equals to 0, and its auxiliary equation is m cube plus 1 equals to 0. Let us find out the first factor. So let m equals to take the -1. So -1 whole cube plus 1 equals to -1 plus 1. it is equals to 0, then m plus 1 is a factor of auxiliary equation. So then by using the synthetic division method, let's find out the remaining two factors. So first write the coefficients of the auxiliary equation. Here the coefficients are m cube coefficient 1, m square coefficient 0, m coefficient 0 and constant 1. And the first m value is what? Minus 1. So your first number will come as it is, 1 into minus 1, and add these two numbers. So minus 1 into minus 1 plus 1, add these two numbers, 1 into minus 1 minus 1, here 0. So therefore m cube plus 1 equals to, the first factor is m plus 1 into, these are the coefficients of the second factor, m square minus m plus 1 equals to 0. So then m plus 1 equals to 0, m square minus m plus 1 equals to 0. Here m equals to minus 1. Here factorization is not possible, then find out the, use the formula, that is minus b plus or minus under root b square minus 4ac divided by 2a. So minus b, minus b value, m coefficient is a b value, so minus 1 plus or minus under root b square minus 1 whole square minus 4 into a value, here m square coefficient is a value, c value is constant, divided by 2 into 1. So m equals to minus or minus plus 1 plus or minus under root minus 1 whole square plus 1, 1 minus 4 is minus 3 divided by 2. So here first root is minus 1, next m equals to 1 plus or minus root minus 3 can write as a root minus 1 into root 3 by 2. So m equals to 1 plus or minus root 3 into I by 2, then m equals to 1 by 2 plus or minus root 3 by 2 into I. So here one root is real number and the remaining two roots are complex numbers. So therefore the solution is, for real numbers the solution c1 into e to the power of m1x. Next for complex roots the solution is e to the power of alpha x bracket of c2 into cos beta x plus c3 into sin beta x, So therefore it is equals to y equals to c1 into m1 value, that is minus 1, so minus 1 into x plus e to the power of, here this solution compare with alpha plus or minus beta I. So alpha value 1 by 2, beta value root 3 by 2. So 1 by 2 into x bracket of c2 into cos root 3 by 2 into x plus c3 into sin root 3 by 2 into x. So then y equals to c1 into minus c1, sorry, here actually c1 into e to the power of minus 1 into x. So c1 into e to the power of minus x plus e to the power of x by 2 into c2 into cos is our required answer. Second question, dq plus 3d square minus 4 into y equals to 0. So its auxiliary equation is mq plus 3m square minus 4 equals to 0. So first I am going to substitute one m value, that is 1. So 1 cube plus 3 into 1 square minus 4 equals to 1 plus 3 minus 4. 1 plus 3, 4 minus 4 equals to 0. So therefore m minus 1 is factor of auxiliary equation. Now using the synthetic division method, first write the coefficients of auxiliary equation. So that is 1, 3, and here m term missed, so its coefficient is 0. Next to minus 4. So here first m value 1. Here write the first number as it is. 1 into 1 1, 1 plus 3 4, 4 into 1 4, 0 plus 4 is 4, 4 into 1 4, minus 4 plus 4 is 0. So therefore m cube plus 3m square minus 4 equals to 0. So m minus 1 into m square plus 4m plus 4 equals to 0. So m minus 1 into m square, 4m can write as a 2m plus 2m plus 4 equals to 0. So m minus 1 into here take the m common, m plus 2, next to 2 common, m plus 2 equals to 0. M minus 1 into m plus 2 into m plus 2 equals to 0. M minus 1 equals 0. M plus 2 equals to 0. M plus 2 equals to 0. Here m equals to 1. Next m equals to minus 2. Here m equals to minus 2. So the roots are real numbers and two roots are equal. So then the solution is y equals to c1 into e to the power of m1x plus c2 plus c3x into e to the power of m2x. So y equals to c1 into e to the power of m1 is 1 into x plus c2 plus c3x into e to the power of m2, that is minus 2 into x. So y equals to c1 into e to the power of x plus c2 plus c3 into x e to the power of minus 2x is our required answer. Third question, d cube y by dx cube minus 7 dy by dx plus 6y equals to 0. So it's a symbolical representation is d cube minus 7d plus 6 into y equals to 0. So its auxiliary equation is m cube minus 7m plus 6 equals to 0. Now let's substitute the m equals to 1. So 1 cube minus 7 into 1 plus 6. 1 cube is 1 minus 7 plus 6. 1 plus 6 7 minus 7 equals to 0. So therefore m minus 1 is factor of auxiliary equation. Now using the synthetic division method, find out the remaining two factors. First of all, the coefficients of these auxiliary equations are m cube coefficient 1, next to m square, but m square term not there, that is why 0, next to m term minus 7, constant 6, and here m value 1. Write first number as it is. 1 into 1 1, 0 plus 1 1, 1 into 1 1, minus 7 plus 1 minus 6, minus 6 into 1 minus 6 equals to 0. So therefore m cube minus 7m plus 6 equals to 0. So here m minus 1 into m square plus m minus 6 equals to 0. So m minus 1 into m square plus 3m minus 2m minus 6 equals 0. Then m minus 1 into, take the m common, m plus 3 minus 2 common, m plus 3 equals to 0. So m minus 1 into m plus 3 into m minus 2 equals to 0. Then m minus 1 equals 0, m plus 3 equals 0, m minus 2 equals 0. Here m equals to 1, here m equals to minus 3, here m equals to 2. So here the roots are real and different. So then the solution is y equals to c1 into e to the power of m1x plus c2 into e to the power of m2x plus c3 into e to the power of m3x. So y equals to c1 into e to the power of m1 is 1 plus c2 into e to the power of, let's complete the positive roots, so 2 into x, c3 into e to the power of minus 3 into x. So y equals to c1 into e to the power of x plus c2 into e to the power of 2x plus c3 into e to the power of minus 3x is our required answer. 12th question, d to the power of 4 minus 5d square plus 4 into y equals to 0. So its auxiliary equation is m to the power of 4 minus 5m square plus 4 equals to 0. So let's substitute m equals to 1. So then 1 to the power of 4 minus 5 into 1 square plus 4, 1 minus 5 plus 4, 1 plus 4, 5, 5 minus 5 equals to 0. So m minus 1 is a factor of auxiliary equation. But find out the one more factor, because here m to the power of 4. So let's take the another m value minus 1. So minus 1 whole to the power of 4 minus 5 into minus 1 whole square plus 4 equals 0 equals to minus 1 whole to the power of 4 plus 1. Here minus 1 whole square is plus 1 plus 4. 1 plus 4, 5 minus 5 equals to 0. Then m plus 1 also a factor of auxiliary equation. Now use a synthetic division method. First write the coefficients of the auxiliary equation. Here 1, m4, m to the power of 4 after m cube is required, but there is a no m cube term, so 0, next to minus 5, and m square term after m term is required, so that is why taking the 0, next to 4. Here first m value is 1, so here first number 1 will come as it is, 1 into 1 1, here 1, 0 plus 1 is 1, 1 into 1 is 1, minus 5 plus 1 is minus 4, minus 4 into 1 minus 4, 0 plus minus 4 is minus 4, minus 4 into 1 is minus 4 equals to 0. Now we have a one more m value, that is minus 1. Here first number write as it is, 1 into minus 1 minus 1. So 1 plus minus 1 is 0. 0 into minus 1 is 0. Minus 4 plus 0 is minus 4. Minus 4 into minus 1 plus 4. So it is 0. So therefore m to the power of 4 minus 5m square plus 4 equals to 0. Here one factor is m minus 1. Another factor is m plus 1. Now the third factor is, here are the coefficients of the third factor, m square minus 0 into m minus 4 equals to 0. So then m minus 1 into m plus 1 into m square, 0 into m is 0 and 4 can write as a 2 square equals to 0. Now m minus 1 into m plus 1 into, here a square minus b square formula, a plus b into a minus b equals to 0. So therefore m minus 1 equals to 0, m plus 1 equals to 0, m plus 2 equals to 0, m minus 2 equals to 0. Here m equals to 2, here m equals to minus 2, here m equals to minus 1, here m equals to 1. So here roots are real and distinct. So then the solution is y equals to c1 into e to the power of m1x plus c2 into e to the power of m2x plus c3 into e to the power of m3x plus c4 into e to the power of m4x. Then y equals to c1 into e to the power of m1 1 into x plus c2 into e to the power of minus 1 into x plus c3 into e to the power of m3, that is minus 2 into x plus c4 into e to the power of m4 2 into x. So y equals to c1 into e to the power of x plus c2 into e to the power of minus x plus c3 into e to the power of minus 2x plus c4 into e to the power of 2x is our required answer. 13th bit first problem, d to the power of 4y by dx to the power of 4 plus 18 d square y by dx square plus 81y equals to 0. So its a symbolical representation is d to the power of 4 plus 18 d square plus 81 into y equals to 0. Next its auxiliary equation is m to the power of 4 plus 18m square plus 81 equals to 0. So let's substitute m equals to, if you substituting 1, we will not get 0. So that is why I am substituting minus 1. Minus 1 whole to the power of 4 plus 18 into minus 1 whole square plus 81 equals to 0. So minus 1, sorry, not 0. Minus 1 whole to the power of 4, 1 plus 18 plus 81. So we will not get 0 answer. See here, if you substitute any m value, we will not get the 0 answer. Why? Because here power is even number. Okay, so that is why let us factorize in another way. That is, here m to the power of 4 can write as a m square whole square, and 81 I am writing as a 9 square. So 2 into m square into 9 equals to 0. So a square plus 2ab plus b square formula. So that is a plus b whole square. So a value m square, b value 9 whole square equals to 0. Then m square plus 9 into m square plus 9 equals to 0. Then m square plus 9 equals 0. M square plus 9 equals 0. Here m square equals to minus 9. Here also m square equals to minus 9. M equals to root minus 9. Here m equals to root minus 9. Then here m equals to plus or minus 3i, because root minus 9 equals to root minus 9 equals to root minus 1 into root 9. Root minus 1 I, root 9 3, so 3i. So plus or minus 3i, here also same plus or minus 3i. So therefore the roots are complex numbers. So therefore the solution is y equals to, see here, plus or minus 3i plus or minus 3i plus 3i minus 3i plus 3i minus 3i. Here we have two positive 3i's, two negative 3i's. Okay, so two positive 3i's, first of all, e to the power of alpha x bracket of for two positive 3i's, c1 plus c2x into cos beta x, and for two negative 3i's, c3 plus c4x sin beta x. So next, y equals to, here alpha and beta values required, so that means here plus or minus 3i compare with alpha plus or minus beta I. So here alpha value 0 and beta value 3. So then e to the power of 0 into x bracket of c1 plus c2 x into cos beta value 3x plus c3 plus c4 into x sin beta value 3x. So y equals to e to the power of 0 into x is 0 and e to the power of 0 bracket of, so e to the power of 0 answer 1. So finally c1 into c1 plus c2x cos 3x plus c3 plus c4 x sin 3x is our required answer. 13th bit second problem, d to the power of 4 minus 18d square plus 81 into y equals to 0. So the auxiliary equation is m to the power of 4 minus 18m square plus 81 equals to 0. Here m to the power of 4 can write as a m square whole square minus 18m square I am writing as a 2 into m square into 9. 81 can write as a 9 square. So a square minus 2ab plus b square formula, that is a minus b whole square. So a value m square, b value 9 equals to 0. So m square minus 9 into m square minus 9 equals 0. M square minus 9 equals 0. M square minus 9 equals 0. Then m square equals to 9. M square equals to 9. M equals to root 9. Here m equals to root 9. Then m equals to plus or minus 3. Here also m equals to plus or minus 3. So finally the roots are two positive roots and two negative roots. Okay, so roots are real and distinct. So then the solution is, of course two roots are equal, here two roots are equal, that is why the solution is c1 plus c2x e power m1x plus c3 plus c4x into e to the power of m2x. Then y equals to c1 plus c2x into e to the power of, this is a m1 value, plus c3 plus c4 into x e to the power of minus 3x is our required answer. 14th question, d to the power of 4 minus d cube minus 9d square minus 11d minus 4 into y equals to 0. So its auxiliary equation is m to the power of 4 minus m cube minus 9m square minus 11m minus 4 equals to 0. So first find out one factor. So that is why substitute m value 1. So 1 to the power of 4 minus 1 cube minus 9 into 1 square minus 11 into 1 minus 4 equals to 1 minus 1 minus 9 minus 11 minus 4. So 1 minus 1 minus 9 minus 10 minus 21 minus 25, but it is not equals to 0. Then substitute another m value, minus 1. So minus 1 whole power 4 minus 1 whole cube minus 9 into minus 1 whole square 11 into minus 1 minus 4. Minus 1 whole power 4 is plus 1 minus 1 whole cube is minus 1 minus 9 into 1 minus into minus plus 11 minus 4. 1 plus 1 minus 9 plus 11 minus 4. 1 plus 1 2, 2 plus 11 is 15, 13, minus 9 minus 4 minus 13 equals to 0. So therefore m plus 1 is a factor of auxiliary equation. Now use a synthetic one more factor, because it is a fourth order auxiliary equation. That is why we need to find out one more factor. This time select the m value 2. So then what will happen? 2 to the power of 4 minus 2 cube minus 9 into 2 square minus 11 into 2 minus 4 equals to 0. 2 to the power of 4, 16 minus 8 minus 2 square 4, 4 9s are 36 minus 22 minus 4. So here see, these are all negative numbers, these are alone positive numbers, so we will not get 0. So then go for another m value, minus 2. So minus 2 whole power 4 minus of minus 2 whole cube minus 9 into minus 2 whole square minus 11 into minus 2 minus 4. So it is plus 16. Minus 2 whole cube is minus 8, minus into minus plus 8. Next to minus 2 whole square 4, 4 9s are 36 plus 22 minus 4. So here 16 plus 8 16 plus 8 24, 24 plus 22 46, and it is a 40. So it is 6, it is also not equals to 0. So then go for another number, substitute m equals to 4. So 4 to the power of 4 minus 4 cube minus 9 into 4 square minus 11 into 4 minus 4. 4 to the power of 4, 256, 4 cube 64, 4 square 16, 16 9s are 144 minus 44 minus 4. So 256, here addition of these all negative numbers is 256 equals to 0. So then m minus 4 is another factor, is a factor of auxiliary equation. Now using the synthetic division method, find out the remaining two factors. So first of all, the coefficients of auxiliary equations are 1 minus 1 minus 9 minus 11 minus 4, and the first m value is minus 1. So here first number will come as it is, 1 into minus 1 minus 1, here minus 2 into minus 1 plus 2, minus 9 plus 2 is minus 7, minus 7 into minus 1 plus 7, minus 11 into minus 11 plus 7 is minus 4, minus 4 into minus 1 plus 4 equals to 0. Next to one more m value, that is 4, but write first number as it is, 1 into 4 4, minus 2 plus 4 is 2, 2 into 4 8, yeah 1, minus 7 plus 8 is 1, 1 into 4 is 4, minus 4 plus 4 is a 0. So then m to the power of 4 minus m cube minus 9m square minus 11m minus 4 equals 0 is auxiliary equation. So m plus 1 one factor, m minus 4 second factor, then the third factor is m square plus 2m plus 1 equals to 0. So m plus 1 into m minus 4 into m square plus m plus m plus 1 equals to 0. M plus 1 into m minus 4, m minus 4. Here take the m common, m plus 1 plus 1 common, m plus 1 equals to 0. So m plus 1 into m minus 4 into m plus 1 into m plus 1 equals 0. So m plus 1 equals 0, m minus 4 equals 0. So here roots are real numbers and different, and of course three roots are same, so real and distinct, real and distinct. So then the solution is, the general solution of the given equation is, here already three roots are equal, that is why c1 plus c2 x plus c3 x square into e to the power of m1x plus c4 into e to the power of m2x. So y equals to c1 plus c2x plus c3x square, c3x square e to the power of m1. m1 means these equal values, equal roots are m1, minus 1 into x plus c4 into e to the power of 4x. So y equals to c1 plus c2x plus c3 x square into e to the power of minus x plus c4 into e to the power of 4x is our required answer.